Okay, so picture this. You look up in the sky, it isn't quite the usual blue. Maybe there's this sort of strange, hazy, orangey tint, and you're definitely not in the desert. You could be, I don't know, thousands of miles away, maybe the Caribbean, maybe even the southeastern U.S. What you're seeing, and probably breathing in, is this absolutely massive cloud of dust that started way over in the Sahara Desert.
Yeah, it's really one of the planet's most dramatic natural spectacles, just this huge movement of stuff across continents.
Absolutely. And, well, that brings us straight to our deep dive today. The 2025 Saharan Dusk Cloud Event. People often call it the Saharan Air Layer, or SELO for short. So based on the stack of source material you've shared, detailed reports, satellite images, weather data, scientific papers, our mission really is to unpack what this record-breaking event was actually all about.
Right.
How did it get so huge? What does it actually do when it arrives? And, why does it matter to places so incredibly far from Africa?
Well, what's really striking about this one, and it comes through in the sources, is just the sheer scale this year. And the fact that, dust from one place can have these really complex, sometimes even contradictory effects thousands of miles away.
It really does connect the globe in ways you just wouldn't expect. Okay, so let's maybe unpack how this traveling desert actually gets started. The source material talks about a pretty specific process in the Sahara, right?
That's right. Yeah, it's not just like random wind and kicking up sand. During the hotter months, the Sahara gets incredibly hot, like really hot.
Right.
Think of the desert floor as just this giant radiator cooking under the sun, and this intense heat at the surface creates a lot of instability in the air right above it.
Instability, like heat rising really fast, that kind of thing.
Exactly that. You get really strong convective mixing, basically hot air bubbling up super fast. Then you add powerful winds sweeping across the surface, often tied to, weather systems or even big thunderstorms, and bam, you've got the perfect recipe to lift enormous amounts of loose dust and sand way up high into the atmosphere.
And how high are we talking here? Like really high?
The sources mentioned it can get lofted up to around 6,000 meters. That's about 20,000 feet? Pretty high up.
Wow.
And at that altitude, this really hot, really dry, dust-packed air forms its own distinct layer.
Ah, okay. And this layer, it sits above the cooler, wetter air that's closer to the ocean surface.
Precisely, yeah. And that creates something called a temperature inversion. Within this dust layer, the air actually gets warmer the higher you go. And that acts like a lid, basically. It traps the dust inside and keeps that whole air mass together as it starts to move.
Okay, so it gets lifted way up, trapped in its own bubble, sort of, and then what happens?
Then the prevailing winds take over, specifically the trade winds, which consistently blow from east to west across the tropical Atlantic.
Right.
They act just like a conveyor belt, just transporting this whole Saharan air layer, this SL, right across the ocean. It's a natural thing, happens every year, but, how intense it is varies.
And according to sources, 2025 wasn't just your average year. What made this particular dust event stand out so much?
Well, this year's event was just exceptional in its magnitude. The sources pull out several specific measurements. For instance, the aerosol optical depth AOD hit 0.55 in some areas.
AOD, right. What does that number actually, tell us in practical terms?
Okay, think of AOD as basically a measure of how much sunlight is getting blocked by particles, like dust in the air column above you.
Okay.
A number closer to 0 means the air is really clear. On a typical, pretty clear day over the ocean, you might see AOD values under, say, 0.1.
Right.
During a more normal Saharan dust event, maybe it reaches 0.2, perhaps 0.3. So getting a reading of 0.55, which the sources reported for this event, that indicates a really dense plume.
So a lot of dust.
A lot of dust packed into that air, yeah. It means dramatically reduced visibility, that noticeable haze we talked about.
So that 0.55 number isn't just abstract data. It means you could really see it, probably feel it in the air. How big are we talking? How vast was this plume?
Yeah, the sources give some pretty impressive dimensions for when it was peaking over the Caribbean.
Yeah.
It stretched roughly 3,200 kilometers. That's about 2,000 miles.
Wow.
All the way from Jamaica past Barbados. And it was about 1,200 kilometers or 750 miles wide, covering the area from Turks and Caicos down to Trinidad and Tobago. Meteorologists were calling it the most significant dust intrusion of 2025.
And it didn't just hang out over the islands, did it? The sources said it kept pushing west.
That's right. Yeah, the forecast showed it heading for Florida and the U.S. Gulf Coast, spreading into states like Georgia, the Carolinas, Louisiana, Texas.
So pretty widespread.
Very. And while this whole transatlantic journey is seasonal, usually peaks around June, July, just the sheer scale and the density of this year's event made it especially noteworthy and, frankly, concerning.
Okay, so you've got this immense cloud packed with fine dust crossing the ocean. What does that actually mean for you, if you're living in one of the places it hits? Let's talk about the health side of things.
Yeah, this is a really major concern, and it's highlighted quite a bit in the source material. Saharan dust is absolutely full of particulate matter. The sources specifically call out PM10 and PM2.5.
Right, PM10, PM2.5. We hear those terms, especially with air quality alerts, but what do they actually mean? Like the numbers?
So PM just stands for particulate matter. The number is the size of the particles in micrometers. PM10 means particles less than 10 micrometers across.
Okay, how small is that?
Well, put it this way. A human hair is about 50 to 70 micrometers thick. So PM10 is roughly maybe a fifth the width of a single hair.
Tiny.
Tiny. And PM2.5 is even smaller, less than 2.5 micrometers. Much, much smaller.
And why does that size difference matter so much?
It's all about how deep they can get into your respiratory system when you breathe them in. PM10, you can inhale it, it gets into your lungs. But the really tiny PM2.5 particles, they can travel much deeper.
Deeper.
Yeah, right down into the smallest airways, the alveoli, and potentially even cross into your bloodstream. And that's what makes them particularly hazardous to health.
Okay, so this isn't just like nuisance dust making things dirty. It's genuinely small enough to cause some serious health problems. Who's most at risk then, according to the sources?
The sources really emphasize that vulnerable populations feel it the most. That's typically children, the elderly, and really anyone with pre-existing conditions.
Like asthma.
Exactly. Asthma, allergies, COPD, other chronic respiratory issues, or even cardiovascular diseases, their bodies just don't cope as well with the extra stress.
So what kind of symptoms or problems might someone actually experience?
The reports list quite a few. Things like making asthma and COPD symptoms worse, more respiratory infections, general irritation of the airways, coughing, shortness of breath, also eye irritation, skin irritation.
Makes sense.
And there are potential links, especially for those with existing heart conditions, to cardiovascular stress.
So if you were maybe experiencing unusual breathing problems, or maybe your eyes were really itchy during this hazy period, the dust cloud could very likely be the culprit.
It's a strong possibility, yes.
And are there standard recommendations? Like, what should people do if they're in the path of this dust?
Yeah, health authorities are pretty consistent on this. The sources all recommend minimizing your exposure as much as you possibly can.
Meaning stay inside.
Stay indoors, yeah, as much as possible, especially when the dust levels are really high. Using air purifiers with HEPA filters indoors can make a big difference.
Okay.
If you absolutely have to go outside, wearing a mask, particularly a good one like an N95 or similar, can filter out a lot of those fine particles. And protecting your eyes, maybe with glasses or sunglasses, is also a good idea.
That all seems like sensible advice.
Yeah.
The sources also mentioned something about water sources being affected.
That's right, yeah. It's a point people might not immediately think of. The dust can settle and contaminate open water sources, things like reservoirs or maybe uncovered wells. So covering those and ensuring water treatment is adequate is actually pretty important for community health during these events.
That's a really crucial point. Yeah, easily overlooked. Okay, let's shift gears a little bit. Because while the health impacts are clearly negative, the sources also talk about some, surprisingly beneficial effects this dust can have on the environment and even the climate.
Right. This is where you really see the incredible complexity of, Earth's systems at play. Because while the dust obviously degrades air quality and produces sunlight getting to the surface, it also acts as this vital transporter of nutrients across the ocean. It carries essential elements, especially things like iron and phosphorus.
Like a fertilizer delivery service.
Kind of, yeah.
Okay.
A massive dusty one.
And where does this Saharan fertilizer end up making a difference?
Well, it gets deposited into the ocean and also onto land when it rains out or just settles. The sources specifically note that this nutrient boost is actually crucial for nourishing marine ecosystems way out in the Atlantic.
Okay.
And also for fertilizing soils over in the Americas. It significantly contributes to the health of massive ecosystems like the Amazon rainforest.
Wait, so dust from a desert in Africa is literally helping to feed the Amazon rainforest in South America.
That's exactly it. It's a really powerful long-distance connection.
That's incredible. And you mentioned it affects hurricanes, too. How does that work?
It does, yeah. The Saharan Air Layer itself, remember, it's hot, it's dry, and it's full of dust.
Ah.
It's actually quite hostile to the development and strengthening of Atlantic hurricanes.
Hostile? How?
Well, a few ways, really. First, that layer of really warm, dry air way up high, it actually suppresses the deep, moist thunderstorms that hurricanes need to form and get stronger. It sort of stabilizes the atmosphere.
Oh, okay. Puts a lid on things.
Kind of, yeah. And second, the dust particles themselves reflect some sunlight back into space. This can slightly cool the sea surface temperature underneath the dust plume.
And hurricanes need warm water.
Exactly. So slightly cooler water makes conditions just a bit less favorable for them to intensify.
That's fascinating. It's almost this paradoxical balance, isn't it? Dust that's bad for your lungs might actually reduce the risk of a major storm hitting the coast.
It's definitely a complex interplay.
But there are environmental downsides too, right? Even with the nutrient thing. It's not all good.
No, it's definitely a case of too much of a good thing sometimes. While, some nutrient input is beneficial, excessive amounts, especially from these really intense events like the 2025 one, that can cause harm.
How so?
Well, the sources point to potential issues like overfertilization that can trigger harmful algal blooms in coastal water.
Right, those red tides and things.
Exactly, which can harm marine life, including coral reefs. And also, if the dust layer is thick enough for long enough, it can reduce sunlight so much that it actually disrupts photosynthesis in marine plants and even some land plants. So it's a really delicate system where the dosage matters a lot.
Yeah, I can see that. This level of intensity, the 2025 event, and these kind of dual impacts. Yeah. It sounds like something scientists will be watching really, really closely.
Oh, absolutely. The 2025 event in particular is seen by scientists as potentially part of a broader pattern, maybe increasing intensity, maybe increasing frequency of these big outbreaks. And that obviously raises important questions about whether other factors are playing a role, changes in global wind patterns, maybe desertification, making more dust available, climate variability.
I remember back in 2020, there's that huge one they called the Godzilla dust cloud. That seemed massive at the time, too.
Exactly. Events like that 2021 and now this 2025 one, they really drive home the need for more research to figure out the long-term trends and what's actually driving them. Monitoring these events is just critical for everything from, day-to-day air quality forecasts and protecting public health, right up to understanding their influence on global climate models and entire ecosystems.
How do they even track something this huge moving across an entire ocean? It seems like a massive undertaking.
It is, but they have a whole suite of tools, really. Satellites are key. They give you that crucial bird's eye view, letting you track the plume for thousands of miles. Okay.
Then you have ground-based sensors, networks of instruments that actually measure the dust concentration and particle size in the air at specific locations when the plume passes over.
Right, like the air quality monitor.
Exactly. And then there are sophisticated atmospheric models, computer simulations, that help predict where the dust is likely to go, when it might arrive, and roughly how dense it might be.
So it's a combination of observation and prediction.
Precisely. It takes all of it to get a good handle on these events.
So this 2025 Saharan dust event, it really is this powerful kind of real-time demonstration of just how interconnected our planet actually is.
It truly is, yeah. It just highlights so clearly how natural processes happening in one specific region can have really tangible, far-reaching consequences influencing weather, climate, health, ecosystems, all on distant continents.
Okay, so just to briefly recap then, based on all the source material we've gone through, we've looked at the natural process, often pretty turbulent, that lifts dust from the Sahara way up high.
We saw how the exceptional scale of the 2025 event, measured by things like that 0.55 AOD value and just its vast physical size, made it particularly noteworthy this year.
Right, a standout event.
We also talked about the very real health implications from breathing in those fine particles, especially, for vulnerable groups, kids, the elderly, people with existing conditions.
Crucial point, yeah.
And then there's that surprising dual role the dust plays, environmentally acting as both this vital nutrient source for ecosystems thousands of miles away and potentially suppressing hurricanes.
But also capable of causing harm, like algal blooms when the concentration gets too high. That balance.
Yeah, that complex balance.
So understanding these events and keeping a really close eye on them is clearly vital. both for, immediate public health warnings and management, and also for piecing together the bigger, complex puzzle of our global climate system.
Right. So as this dust continues its journey or eventually dissipates, the advice from the sources is for communities to stay aware, take those precautions we talked about.
Stay informed.
And scientists are obviously continuing their crucial work, studying not just this event, but the long-term significance of these massive dust transport.
Absolutely. And, it really leaves you with a truly thought-provoking idea, doesn't it? Just consider how something as seemingly simple as wind blowing over a patch of desert thousands of miles away can literally change the quality of the air you breathe, potentially influence whether or not a hurricane forms off a completely different coast, or even impact the health of fragile coral reefs far out in the ocean.
It's a stark reminder.
It really is. A fascinating and maybe slightly unnerving reminder of Earth's incredibly interconnected systems and how events on one side of the world can genuinely resonate, sometimes quite dramatically, on the other.